AP Chemistry, Unit 4.6, Introductions to Titrations. Titrations can be used to determine the amount of an analyte within a solution. The titrant has a known concentration that reacts specifically and quantitatively with the analyte that has an unknown concentration. The equivalence point in a titration occurs when the analyte is totally consumed by the reacting species within the titrant. The equivalence point is often indicated by a change in a property, such as color, that occurs when the equivalence point is reached. This observable event is also called the end point of the titration. How we're going to set up a titration is by using either a volumetric pipette or graduated cylinder, accurately measuring the analyte of unknown concentration into an Erlenmeyer flask. You would then add several drops of an indicator to the flask, and then set up a ring stand with either a single or double burette clamp. You would then rinse the burette twice with DI water and check for any clogs. You are then going to rinse the burette with the titrant and then fill the burette using a funnel, draining a small amount into a waste container so that the tip of the burette is also full of the titrant. You will then record your initial volume of the titrant. You would then go ahead and place the analyte flask under the burette, and you might want to consider placing a piece of white paper or something else of light color underneath the flask so that you can see the color change more easily. Here we have an illustration of what a setup titration experiment could potentially look like. So we will have a stand, our flask with our analyte of unknown concentration, and our burette full of the titrant of known concentration, and then we are adding the titrant to the flask of the analyte. We are slowly adding the titrant to the analyte, and we are constantly swirling. The actual indicator will potentially change color early, but the color might not last, and so adding that additional swirling motion can help to see if this is a true endpoint or if it is not. You are going to only stop when the indicator changes color and then stays that color even after swirling. You will then go ahead and record the final volume of the titrant that you needed to add. For equivalence point calculations, the typical path for calculations are as follows. You will go from the volume of the titrant, which is typically going to be measured with milliliters, to liters of the titrant, utilizing the conversion between liters and milliliters. Once you're in liters of the titrant, you can go ahead and get to moles of the titrant, utilizing the concentration of the known titrant. And then you will be able to convert from moles of titrant to moles of analyte, utilizing the mole-to-mole ratio. And then finally get to the concentration of the analyte based off of the initial volume that you had for your analyte.